Can we make a flame-proof balloon? Yes, and also no. By the end of this episode, we are going to have a balloon over top of a flame and it's not going to pop. How? Well, by using magic, of course. No, we're going to use science and heat dispersion. It's very cool. First, let's show you the effect that we don't want to replicate. So we have a lonely little flame here. I'm going to blow up a balloon. Okay, using your scientific brain, what do you think is going to happen if I bring this balloon over top of the flame of the candle? If you said explode, you'd be right. It destroys the balloon and the flame. That's not very uncommon. However, what if I told you there was a way you could hold the flame directly underneath so the flame is actually touching the rubber of the balloon, but the balloon will not pop? How is this possible? Is it magic? No, it is not. It is science. All right, this brings me to my second point. Water is amazing. Seriously, water does things that nothing else does. The fact that it expands when it's cold by itself is amazing. Also, the fact that its boiling temperature and freezing temperature occur naturally on Earth that we can replicate, so cool. All right, with that being said, let's get into this. Water, in its liquid form, cannot get above 100 degrees Celsius in normal atmospheric conditions, because at 100 degrees Celsius, it boils and it uses up all of the extra energy that we're pumping into heat, into the boiling and turning into steam. So if you have any liquid water at all, you know that that liquid water cannot be more than 100 degrees Celsius. Guess what the melting temperature of a balloon is? Well, actually, I don't know, and I could look it up, but I didn't, so suffice to say, it's over 100 degrees Celsius. So, what we're going to do, we're going to pour just a little bit of water into this balloon. Right here. I am making a mess, but that is okay. Okay, so there's just a little bit of water inside this balloon. I'm going to blow it up. Do you see that water kind of sloshing in there? It's not much, but there is a little bit of liquid water inside of this balloon. Now I'm going to light this candle again, just so that we have a nice flame. Now we showed you what happened when this flame touched the rubber of a balloon. It melts it and it pops almost immediately. However, we have a tiny little bit of water inside of this balloon. So, if we make sure that that flame is only touching the rubber that is directly below the water that's inside this balloon, the heat will be transferred through the rubber into the water, and the water will disperse it instantly. Well, not instantly, but very, very quickly. And that dispersion of heat will continue until the water boils. So there's no way, in theory, this flame can pop this balloon as long as that layer of water is directly above the flame. Let's try it out. This might actually pop, I don't know. Look at that! That flame is touching the balloon perfectly. Now watch what happens when I bring it. Woohoo! So what I was going to say is watch what happens when I bring the balloon slightly to the side when the flame touches the rubber that isn't directly underneath the water. But you just saw exactly what happened. It pops very, very quickly. I have to clean up my studio. I'll be back. So that was quite disappointing because you can't really see it from that angle, but that just sprayed water and soot all over my lab. So if you do this at home, make sure you do it in an area that you don't mind getting sooty and wet. So, with that being said, let's try this one more time. This balloon does have a little bit of water in there, and we're going to try this. This time in a more controlled way. I mean, everything's wet and dirty anyway, so. Now I'm going to show you unmistakably that this flame is actually touching the balloon. We'll bring the balloon down. Make sure that it's directly over the water. Look at that, eh? There's nothing except for a little bit of soot that's on the balloon because that's just what's coming off of the candle. But the rubber isn't even hot in the least. Let's try that again. That's incredible. That really makes me scared. I don't want to clean up again. That's so cool. Water is incredible with its heat dispersion. Oh, this is cool. Here, watch this. Do you see that? I just lit the candle with the smoke of the candle. And if you want to find out why, I made an episode on that. So you can go check out that video. I'll try it again. Whoop. That's cool. That's totally off topic. Stop it. Stop getting distracted. Okay. So, campfire trick. Say you're out camping with your friends and you all have like the traditional styrofoam cups with you. Styrofoam cups burn very easily, and I don't recommend burning them because they give off some nasty fumes that aren't really healthy to inhale, but inevitably people throw them into the fire. But did you know you can actually boil water in a styrofoam cup? What? How does that work? Well, if you fill a styrofoam cup with water, you can put that styrofoam cup in the fire and it won't burn up as long as there's water inside of it. In fact, the outside edges will melt away up to the level of the water. Now let's head outside and I'm going to show you exactly what I mean. It's a cool effect. Welcome to the portion of the episode that I forgot that my microphone was off, so I'm going to badly lip sync this. Okay, so we have two cups, one that has no water in it and one that does have some water in it. And I'm going to actually place these in the fire and then we're going to show you exactly what happens to each individual cup. One of them is going to melt and the other one is not. Okay, let's try this out right now, just placing this on the edge of the fire. By the way, I don't recommend playing with fire. There we go. You can see that one of the cups, the one without the water, is melting away from the massive heat of the flames. But the water inside the other styrofoam cup is dispersing the heat so well that there's no heat left to melt the styrofoam cup. That's amazing. And this will actually continue on until the water has fully boiled. And it will continue to protect the styrofoam until the water is all boiled away. As you can see, the styrofoam has melted down exactly to the level of the water. That's just where the heat is being dispersed. Isn't that cool? That's really cool. Thanks for joining me in this fun episode of balloon science and fire science and explosions and all that fun stuff. I'm Jonathan Allers and this is Destructive Creativity. We are here for you, for science and for fun. So make sure you hit that subscribe and like button. It really helps us out. See you next time. Bye.